Okay, welcome to Pandas, data science package that is very, very powerful of handling data, manipulating data, and used a lot in data munging and data cleaning and data pre-processing and whatnot. This Pandas basically is built on top of NumPy, so most of the features of NumPy is also available in Pandas. Let's dive in. I mean, this Pandas is a very, very fancy library, very, very fancy package that you can handle very large amounts of data in CSV files or in Excel files, wherever the data is located, the missing entries are there. You can handle all the data, you can manipulate all the data, you can prepare all the data in just a few lines of codes using this Pandas package. So let's just start Pandas package. There are two most important objects of Pandas. One is series, another is DataFrame that we'll see later on. There is one more index, but the most important one is, or the useful one is series and DataFrame. So let's just define. First of all, you need to import Pandas package. Import Pandas, and you can rename this as PD. That's the most popular renaming, although you can rename it any. And then you just say, okay, pd.series, and then just like a NumPy array, you pass the data that you want, and you can create your own indices. For example, just like dictionary, this A is a key value. This A is a key or index for this 0.25. This B is index for 0.5. C is index for 0.75, and D is index for 1. So you can supply your explicit indices as well. If you do not supply the indices, the default indices are 0, 1, 2, and 3. But you can define your own indices in the way you want. Now, once this data object is created, you can call the data values, and you will find out the values. You can call data.index, and you will find out the indices. Let's see in the Jupyter notebook just to get comfortable with Pandas. First of all, import Pandas as PD, maybe, or something else. So, okay, that's imported. Maybe we can check what version we are working in. pd.version. The version of Pandas we are working in right now is 0.24.2. Fine, great. So let's create data or whatever variable, let's say A, as pd.series, and there we just give a list of some values, 2, 3, 4, 5. Let's say these are the values, and then we can give index as another list. Let's say the indices are A. Maybe the indices need not to be strings. Anything A, B, C, and let's say the index of 5 is, let's say, D. So now the series object or the Pandas object series is created. Series basically handles one-dimensional arrays. Later on, we will see DataFrame handles multi-dimensional arrays, I mean more than one dimensions. Normally, typically two-dimensional arrays. But, okay, A dot values. So let's call the values, and you will get all the values inside the series. And by the way, this values array that you get, let's check what's the type of that array. What's type of that array? A dot values, what is that thing? That's a NumPy array. Wow. And what's the type of A itself? That will be a Pandas object. Great. So everything inside Pandas, the NumPy is playing all the role inside Pandas. Great. So now let's check the index, A dot index. That's also an NumPy. That's also an array of index type. That's a different. Actually, index is also an object in Pandas. That's an index type object with these kind of indices. We can access, for example, this A, just like we are working with dictionary. For example, A of A, that returns a value. We can change the values. We can add different. We can add more key value pairs. So just think like these And just think this data just like the dictionary object that we saw. These are the keys and these are the values. And this is one very good way of remembering what the series does and manipulating series the way we want. Okay, we can access A like this. We also can do slicing. Let's say we want to access from A to, let's say, C. Let's say we want to access all these. One difference is when you access like this, in the normal slicing using implicit indices, for example, 1, 2, 3, or 0, the final index is not included. But if you access like so, using explicit indices that are there, the final index is also included. So that is one more fancy way of indexing using in this pandas. Okay, great. That's a series object. By the way, we can create a series object by first creating a dictionary. For example, let's go back to our slides and see this example. Let's create a dictionary, for example, of grades. Let's say we have a lot of students with grade A minus, grade B minus, and let's create that dictionary. Then we can just create a series object or pandas object by just passing this dictionary inside. We can make another dictionary, for example, and we can make another series object. So one way of defining the series object is just to pass the data as well as index. Another way is to just first create the dictionary and just pass the dictionary variable inside, and the series object will be created. Okay, that was just the introduction to series. We will move on and see more features of pandas as we explore it more and more in the upcoming videos. Hope to see you in the next video. Okay, let's say we have two different dictionaries. Let's say we have a lot of students, and the A grade is defined to be 4, and the A minus grade defined to be 3.5. The B grade has a number 3. The B minus grade has a number with a numeric value that is 2.5, and similarly B grade has a numeric value that's a 2. And then we create just a series object using this dictionary. Let's say rather than just numeric values as GPAs or something like so, let's say A grade also is defined at 85 marks in total. A minus grade is defined at 80 marks in total, and similarly these. And then we create another series object, let's say named with marks using these pd.series. So let's go to Jupyter Notebook and just play a little with these dictionaries and build the series object. Let's say marks, or let's say grades dictionary equals, let's say A grade is has A grade has number value 4 or GPA value 4. Let's say we have a B grade with GPA value, let's say B is, let's say, 3.5. Let's say we have C grade with GPA value, let's say 3. And let's say finally we have D grade with GPA value, let's say 2.5. Let's say that's a dictionary. Okay, what we do now is we create a grades series object, let's say, using pd.series, and just pass this grades underscore dict. Now this capital A, capital B, capital C, and capital D, they will act as indices, and this 4, 3.5, 3, and 2.5, they will act like values. So for example, if we call that and just now call grade dot values, so we will get, for example, well, what is that? That just values. Let's say we get this grades.values, and we get all the values that are available. Similarly, if we find grades.index, we will find out A, B, C, and D. Let's define another dictionary, for example, marks dictionary, dict, and that is, let's say, again, the total marks are 85 for the A grade. Let's say for B grade, the total marks are, let's say, 75. Let's say for C grade, the total marks are, let's say, 65. And for D grade, let's say the total marks are 55, let's say. So let's say that's another dictionary. Now let's create a series object pd dot series. Let's say marks dictionary. So now again we have, if we just write this marks, just like so, you will see the marks A is 85, B is 75, C is 65, D is 55, and all the values, they are integer 64 kind of values. Now we can access, now we can play with this marks. For example, if we just want to access, for example, what are the marks between, let's say, for example, what are the marks given at A? We can access that, we can change that, we can just play like a dictionary. What if we, rather than using the index A, we use, for example, slicing? We want to start from the very beginning, and let's say we want to go to 2. What will happen? Let's see. Yeah, so the slicing is there. For example, if you want, these are explicit indices, A, B, C, D. These are explicit indices, and they are there. For example, if you can slice the data using explicit indices that you're given, or implicit indices that are the default indices. The first value indexed at 0, the second value is indexed at 2, 1, and so on. So you can do that as well. One catch here, for example, that we will see later on, there may be a problem that your explicit indices, they are also numeric. And then you do the slicing like so, then the series object may be confused whether I have to use the explicit indices or implicit indices inside. We will see how to resolve that issue, but by this pandas allowed to use explicit indices as well as the implicit indices. Okay, we were here. Sorry, I just. So yeah, so we were here. So we have created these grades, a series object, this marks as a series object. The series object is good for one-dimensional arrays or data with just one-dimensional list, or dictionary kind of with just one dimensions. Later we will see data frame that actually is actually the extension of can be looked like as an extension of series towards more than one dimension. We may have, for example, two-dimensional arrays or two-dimensional data structures, something like so. And we will be seeing this data frame, which is much more powerful, particularly for reading data from files and manipulating it and stuff like so. We will see that in the next video, data frame, that running form of data frame in the next video. Okay, in the last video, we were discussing series, and I told you that data frame is basically if the data has if the data is in a form of different columns, for example, a record as an array, then you have another record, then you have another record, and each element in that record is a different attribute. So this particular way of two-dimensional data is very well handled using data frame inside pandas rather than series. So, but you can make these data frame object using different series objects. For example, you have a grades object that we created last time. You have a marks object that we created last time. Let's build a data frame using these two and see what it looks like in Jupyter Notebook. Let's see that. So remember, we have a marks series object, and we have a grades series object. Let's now make grades. Maybe the name is grades. Okay, the name is like grades. Okay, so grades object, this one. Let's make a data frame. Let's say D, or maybe whatever name you want to do. Data frame with, again, that data frame can also be defined using a dictionary. Again, now we have, let's say, marks is the key for data marks, and grades is the key for data grades. Let's say we define a data frame like so. And now if you see, if we just display this D, we get a very beautiful look and feel of, this A is the index, A is the explicit index, at index A, the marks is 85, the grades are 4. At index B, the marks are 75, the grades are 3.5, and so on. That looks like so. Not only that, you can just transpose it like you have transposed the NumPy array, and you will get the flipped variant or the transposed variant if you want. Great. So that's how, and you can have, for example, more dictionaries to concatenate together, and more columns will be added here. And that's what the real data looks like. It has a lot of columns, which normally are attributes, and each row is basically one record or one sample of the data that you want to work on. So this data frame is really, really ideal data structure for working with files, having a lot of records, and you want to manipulate that data and stuff like so. So yeah. So one more thing. Let's access the D, for example. Let's print D. That's the D. Let's access the values inside D other than no. So what are the values? So the values inside D is completely, again, a two-dimensional array that is completely like so. So for example, if you want to access this particular element 65, that is row number 3 and column number 1, excluding the indices. That's row number 3 and column number 1. So we can access that particular value, d.values, just assuming that's a two-dimensional NumPy array. Row number 3 is 2, indexed with 2, and column number 1 is indexed with that, and we will be able to access 65. Wow, great. So that is there. There are more things that are available. D dot, for example, columns, D dot columns. Columns, it will give us what are the columns. The columns are marks and grades. There are other properties, and there are other several properties that we need to know. RS, for example, this there we define this as d dot index and stuff like so. Okay. One more thing that you need to know is we right now we have, let's say, D, that is this one. That's D. Let's say we want to add another column here. We want to add another column here. And that is the name of that column is scaled marks. And the scaled marks are, what if we have computed marks rather than from 100? What if we have computed marks out of 90? What are the scaled marks out of 90? So one way to do that, and very quick way to do that, is just like a dictionary, again like a dictionary. You just add a new key, let's say scaled marks. That's a new key. And the value is simply all the marks column divided by 90. So is that true? No. Divided by 90. If we have just computed all the marks by 90, and then how can we compute the marks from 90? It is rather than 100. It is from 90. I guess. How can we compute the marks from 90? If you want to compute the marks from 90, I guess they will look like divided by 90, and maybe 100 is multiplied here. I guess maybe the formula, I guess that's what it is, I guess. Let's see. So now if you see D, there will be another column that is there. And it does something else. Anyways, it does something that, yeah. So something. Anyways, so we've just computed this. We just inserted that column inside that. That is a processed version of these kind of values. Maybe we have added this column in a very wrong way, and later on we suggest that, okay, we should delete that column. Well, that's very simple. Again, using the concepts again, just like the dictionaries. Delete this, and this column is deleted from data, and you're again with the data that you had. So you can add columns, you can delete columns, and indexing is really fine. I mean, indexing like masking. Let's say you want to pick, for example, or you want to pick the data frame such that you want to pick all the records such that the marks are greater than, let's say 70. You want to pick all the records where the marks are greater than 70. This is that simple. All the data will be copied into G with this condition. And this condition can be arbitrarily complex using ands and ors and combinations and all that stuff. And you have seen this kind of stuff in NumPy as well. I mean, this is called masking. Great. So that's available in Pandas as well. Okay, so that's how you can index. In the next video, I'm going to basically show you one type of problem that normally happens in real data, that is the missing value problem. Sometimes you read a data and some of the attributes or some of the row column pair values, they are just missing. I mean, they're not available due to certain reasons. How can you handle those values, and how actually Pandas suggest you to handle those kind of missing values, which is sometimes called NaN values or none type values also. They mostly used interchangeably in Pandas. So in the next video, we are going to handle or see how to handle missing data in Pandas. Hope to see you in the next video. Okay, in the last video, we saw data frame object, and we saw actually how to add and remove columns, how to process data, how to index, how to actually mask, or how to apply conditions and selections in Pandas. We saw that very briefly, but in this particular video, we are going to see one kind of missing value, sometimes called NaN, or not a number, or maybe not anything, or sometimes this none type, none, which is the default return type of any function in Python. This none type is also sometimes in Pandas is treated as NaN, or NaN is treated as none, or interchangeably anything. Let me give you what do we mean by that. Let's say we have two dictionaries. Let's say one dictionary is A with key value A, and the value is 1, then B, and the value is 2. Okay. The other dictionary is B and C. So for example, that is one record with columns A and B. So A and B are the columns. On the first record, the value of A is 1 and the value of B is 2. Now let's say we want to insert another record in the same data frame. Now the value of B is available in the second time. The value of B is available, which is 3. And the value of C is available, which means a C column is added now. But for the value C, the first row value is not available, so we will say this value is missing here, but in the second row we have 4. Similarly, the value of A is missing for the second row, and that is a missing value, which is sometimes called NaN. So these are missing values, and they are typical when you are working with data and you're reading data and you're getting data from somewhere, or large files and stuff like so. So Pandas give some methods to handle these kind of this kind of situation. Let's say A equals PD dot data frame, again a dictionary. Let's say we have A 1 and B, let's say 4, that's the first row or record. The second record, let's say, is another dictionary. Let's say B is -3 and C is, let's say, 9. Let's say that's our data frame A. So now if you print this A, if you see the data inside A, you will see, oh, what's the problem? A is this, and B, have we applied something in a wrong way? Let's see. Oh, we have to create a list. That's the, okay, we have to create a list of it. We have to create a list of dictionaries. That's the proper way of calling it. So we missed just the syntax list of that. Okay, great. So now we have this A, we just call that A, and this value is missing and that value is missing. And in large data files, this is typical. I mean, there are a lot of values that can be missing. One way that Pandas applies to handle these missing values is to just fill these missing values with some fixed number. For example, there is a fillna function, and let's say you supply 0. That means wherever there is a not available or not a number value, fill that with 0, or maybe any value you want to fill that with. So that is one way to do that. And now if you see the value of A is all the non-values are filled with that. Another kind of function that is available in Pandas that is sometimes used, that is dropna, that function dropna. What that does is it drops all the records that contain a missing value. Sometimes if that is feasible, I mean, dropping all the records that contain missing values, if that is feasible, then go for that. But if the missing values are a lot and they are spread over a lot of rows, then dropping all those kind of records, they will create a lot of data loss, and then it become really important how to handle these missing values. However, you can fill the missing values using fixed value, or you can drop them. And later on, we will see in scikit-learn that there are other ways of handling the missing values as well. You can fill each column missing values in each column using an average, or using, for example, a regression. There are ways to handle these missing values. But in Pandas, these two functions are right away there. You can fill all them with a fixed value, for example, or you can drop them and you are ready to go. Okay, great. Next, we are going to see, as I mentioned earlier, what is a confusion between, what if there is a confusion between implicit and explicit indices? And that I will discuss in the next video. Basically, just to give you a look and feel, what if the explicit indices you supply, they are 1, 3, and 5, and what if you call this particular command 1:3? Will it call the implicit index or the explicit index? That's a problem. So we will see, because 1:3, 1 and 3, they are also explicit indices. And whether this 1:3 is referring to the implicit indices that are default indices, or they are referring to these indices. So this confusion is there, and we will see how to handle that confusion using this log LOC function and index log ILOC function. We will see that in the next video.